All right, hello everyone. So today we're going to be looking at this trigonometric function, which we're going to graph y equals 2 cosine quantity 3x minus pi over 2 plus 2. And we're going to graph that over one period. First thing I'd like to do is to look at these two equations here. Y equals a cosine quantity bx plus c plus d, and then y equals a sine quantity bx plus c plus d. And these are like your standard equations when you're graphing trig functions. Each of these letters represents something, okay? And let's go over that real quick. So you have what we call your amplitude, your period, your phase shift, and your vertical shift, okay? So for our amplitude, that's kind of like standing in a way for the vertical stretch or shrink of a graph. For those that you know transformations, that's what it stands for. The amplitude is really defined to be, you're looking at trigonometry, the highest value of your graph, the y value minus the smallest value divided by 2, something like that. I'm not going to go into that, but just to provide some background information on that. So that's what the amplitude is. Your period basically is how long it takes the graph to do one full cycle. That would be 2 pi over b, and that is kind of like the horizontal stretch or shrink of a graph. The phase shift is basically the starting point of your graph over the period, quote unquote starting point. It's also your horizontal shift to the left or right. And then finally your vertical shift is pretty much the same here as it was when you're working with transformations, how much you're moving your graph up or down on the y, okay? All right, so let's figure those out here. And it is often the case that you're asked these questions in the graph. Do I need to write them down technically? No, but it's good to have them, really. The amplitude is the absolute value of a. It's just the absolute value, in this case of 2. It's just the number that's in front of the function stuff. The period is 2 pi over b, so it's 2 pi over 3. So your one full cycle will be 2 pi over 3 units. Your phase shift is minus pi over 2, because c is minus pi over 2 divided by 3, which is pi over 6. And then your vertical shift is just 2 units. So again, the phase shift tells you how much, where your starting point is, quote unquote, on your graph here. And the next thing I like to do is this. This is really important. And I highly recommend that if you're not familiar with the graph of cosine or sine over just the graph of just plain cosine of x and sine of x over one period, that period 0 to 2 pi, I highly recommend you go over that first, okay? Because it's with the method that I'm going over, you need to know what the graph looks like to graph the graph we're asked for. And also, just in general, knowing whatever other method you're gonna look at, if you don't like what I did today and you prefer to watch another video or speak to a tutor or classmate, I suggest you just know the graphs again, because they usually will go over those graphs again. So I want us to notice a few things about this graph of cosine of x. You have 5 key points really that are standouts here. You have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1. Now, what we're going to start off by doing is we're going to apply our horizontal shifts basically to these points, and we're going to basically move them. So 0, pi over 2 pi, 3 pi over 2, and 2 pi are going to be transformed, essentially is what we're saying. And here's how that works. Your starting point for your new graph is that phase shift, which was pi over 6, okay? That is your new 0. That's like your new starting point. And your end point, like that would be pertaining to where 2 pi is at on the graph of just cosine of x. The way you get that is by using this idea, which is the end of the cycle as the last point is equal to pi over 6. That's your starting point plus your period. Always the case for sine and cosine. So pi over 6 plus 2 pi over 3, 5 pi over 6. So 5 pi over 6 is where your new 2 pi would be. So that's great, but then we need to know what the other points in the middle are, okay? So, meaning where is the new pi over 2 going to be? The new pi, the new 3 pi over 2. And the way this works is, if you notice the graph of cosine of x, that those points are spaced apart equally from each other. So 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi, they're all pi over 2 units away from each other. And what that essentially is that whole period divided into 4 equal parts, right? So yeah, if you have a whole period and you have points that are equally spaced apart, it's the length basically divided by 4 parts here, okay? So that's why we're gonna look at this equation where I have other points as this period is divided by 4. So you get 2 pi over 3 divided by 4. So we're always gonna do that. 2 pi over 3 times a fourth is pi over 6, right here. And that's basically the distance between each of your points. So again, your first point was pi over 6. Your second point, the way it works is you're going to take your first point and add pi over 6, that distance, that's pi over 3. Get your third point, you're going to take your second point, pi over 3, plus pi over 6 to get pi over 2. Fourth point, pi over 2 plus pi over 6, 2 pi over 3. And last but not least, your fifth point, 5 pi over 6. And essentially what we've done here is we've transformed the points which were originally 0, 1. Let me do this in blue. 0, 1. Pi over 2, 0. Pi negative 1. 3 pi over 2, 0. And 2 pi 1. We basically transformed the x values. The y values have not changed for the moment, but now the new values are pi over 6 comma 1, pi over 3 comma 0, pi over 2 comma negative 1, 2 pi over 3 comma 0, and then finally 5 pi over 6 comma 1. So that's what that does here, okay? So now we've located our new x values. However, there's also some y values that we got to take care of. And this, I just wrote out the points, okay, that you'd have here. And yeah, we're gonna have some new y values because the 2 that you see in front of that function multiplies the y values by 2, and then you're adding 2. So how do I get those y values? Well, here's what you do. I'm gonna take each of the points that I just wrote, and I'm gonna take each of the y values, and this is what you do with any graph, this applies. Take every one of your y values and you multiply them by a, by basically the number that's in front of the function. So multiply by a and add d here, okay? So you're adding that vertical shift, okay? So 2 times 1 plus 2 is 4, 2 times 0 plus 2 is 2, and etc. for the rest of these. And your new y values here would be pi over 6 comma 4, pi over 3 comma 2. We have the new x values, and we're just writing the new y values attached with them. So pi over 2, 0, 2 pi over 3, 2, and 5 pi over 6, 4. Okay, and we're going to go ahead and graph these out up here. Okay, so pi over 6, 4. Okay, 1, 2, 3, 4. Okay, that would be here. Pi over 3, 2 is next. That would be here. Pi over 2, 0. 2 pi over 3, 2, and then 5 pi over 6, 4. Okay, 1, 2, 3, 4. And there we go. That is our graph. And basically, the shape does not change. It's really important. The basic shape of this graph does not change. It might have maybe compressed a bit, but it still looks like that cosine graph that we drew earlier. Okay, so that is your new graph. Okay, now a couple of things that I wanted to mention here. Yeah, you could do I did the horizontal shifting first and then the vertical, but you could do it reverse. You can do the vertical shift and the horizontal. It's really up to you. Okay, but ask you to maybe just stick with one way in terms of saying, like, I'm going to do my vertical, then my horizontal, or horizontal, then whatever you choose. But I would recommend that you stay with one first and then the other, because I've seen some people like mix things around and such, where they do a vertical and a horizontal, and it can be done, but it is a little confusing. And so I recommend you don't do that. Like, so anyways, so this is how you would graph this cosine graph, and if you had a sine graph, this applies as well. And I hope this helps, and thank you for your time.